Okay guys, welcome back. This is a continuation from where we left off, and I just forgot to mention one thing. For you to check the state of the PLC, there's an option here that's called hardware. Okay, so this is a representation of the state of our PLC at the moment. As you can see, it is the CPU 0, like we had confirmed before. So I'm just going to set and reset the bits so that you can see how we respond. So I'm just going to call this to make it true. Since it's true now, on the hardware we should see an output that is configured. Okay, so this Q0.0 is now true because as is on the PLC, it is set to true. All right, so now what I want to do is I just want to, stop the PLC and go offline. Okay, and I also want to show something, the PLC state. Okay, here what you can do is you can reset the date of the PLC and to real-time settings. If we go online, you can see that it's showing that today I recorded this video on the 18th of July 2020, and this is around the time that this is happening. So for you to update the time, usually if it comes from the manufacturer, it has an old date and you might want to update it. So what you do is stop the PLC and then you sync to the computer, and after that it's done. It updates the situation, the time, sorry. And with the full tech PLCs, they have a loss of about 100 milliseconds, I think, a day. And according to the hardware details I gave last time, it can go for 30 days without power and still maintain the same time. Okay, so maybe periodically after a very long time you might just need to update the time and stuff like that. All right, now back to our program. Okay, here I'm sure you're thinking, okay, would it not be nicer if we were able to view the names of these variables, right? So what we can do is actually, let me just go offline and we can check our status symbols. Okay, so here we can create the names. Okay, give them symbols. For example, if am I on the right portion? Symbols. Okay, so if I call this internal start and I'll call this external stop, okay, and I'll just call that the external output. We should be able to see these things on our program, okay, just like that. So if you go back and connect to the PLC, now you have a worded or maybe symbolic addresses. Okay, so now what I want to do is maybe use the function blocks as I promised on the previous video. So let me just stop the PLC. No need to stop. Let me just go offline, edit this program. So I'm just going to click here and say new function block. Okay, so we can change the name. We can say, let me call this periodic. Can we change the name? Add parameter, change name, yes. Not in that sense. Okay, so we cannot change the name. But anyways, what we're going to do with this, we want to ensure a periodic timing. Okay, let's say that we have a motor that is connected to our plant, and we want that electrical motor to start and stop at different times, or maybe periodically go start and stop. For such applications, I'm just going to create a simple program that we can do that using timers. All right, so what we're going to do is, in the function block, we need to create a parameter that we're going to transfer to the outside. So that parameter is going to be a Boolean data type, So here basically I would just put a normally open contact. By the way, without clicking, you can simply write NO and it will be normally open. If you type NC, it will be normally closed. So what I'm going to do is I'm going to put a timer. Okay, we go to timer operations like that. Okay, so here I'm going to put 1000 milliseconds. Okay, and this is timer number 1. Okay, and this is the value of the timer. What do we want? Where do we want it to be stored? Okay, you don't really have to store it, but you know, you can do that, which is a good thing. All right, and here I'm just going to, like, we can add a rank by clicking L or right line. Okay, so I'm just going to call that timer again, and this will be 2000. Let's say 2 seconds. This is timer number 2. Okay, so to ensure a periodic because this is L, sorry. So we know that with periodic timing, one timer has to switch on the other one. Okay, and I'll just call this T1. All right, and this is normally closed, which is going to be T2. All right, and here I'm just going to put an output, which is going to be our symbol value. Okay, temp 0. All right. Okay, so this is going to be what we're going to take from our function block. So if we go to the main block, all right, I'm just going to put a rank there, and then I double click here and it shows everything that I need. So I'm just going for the call block. All right, call function block number 0. Put it there, and this is our parameter that we just added. So instead of, so what are we getting from temp 0.x? We are getting q 0.0, maybe, which is the motor output. Okay, so sorry, q 0.1, because we've already used q 0.0. Okay, I'm going to go to our symbols and just write periodic motor. All right, so let's just check if this works. Okay, we're just gonna download our program. Compile failed. Shows that there is a mistake. What is the reason? Let's go to our main blocks. All right. Compile. Okay guys, we're back, and after a little bit of digging, I went through documentation. You can reach this documentation by just pressing F1 on your computer while this program is open. So what I realized that the syntax, or the way we wrote this variable, is wrong. Okay, because I had copied exactly how it is written here. So the way it's supposed to be is actually temp 0, not point X or anything. Okay, so let us try and go back to our main block and see how things work. So I'm just going to try and load it now. As you can see, there's no problem. We didn't face any problem. And load, yes. Stop the PLC, yes. Complete, run the PLC, yes. Okay, so now everything is working. We can check the state of this. So as you can see, our digital input 0.1 is periodically coming on and off. Okay, we can also confirm this by looking at the hardware. So here is our output. It's blinking like that. All right, so that's it for now from the function blocks. In the next videos, we're going to be talking about other things, and stay tuned.